In this video, we will learn the derivatives of inverse function. Derivative inverse function या कैसे find करते हैं? So let's start. So what we have, suppose I'll write the first inverse function, y is equal to sine inverse x. So inverse हटाने के लिए क्या करते हैं? We will take sine of both the sides. So sine y x. Now I'll differentiate. Implicit function बन गया, so we will differentiate. So sine y का derivative cos y, y का derivative dy by dx, x का derivative 1, right? अब dy by dx क्या बन गया यहाँ से? dy by dx is 1 upon cos y. 1 upon cos y को हम लिख सकते हैं अंडर रूट ऑफ 1 माइनस साइन स्क्वायर y. अब sin y क्या था? sin y was x. So 1 upon अंडर रूट 1 माइनस x स्क्वायर. इसी तरीके से हम सारे इनवर्स फंक्शंस को फाइंड करेंगे. जैसे tan इनवर्स है, so I'll just write tan inverse x, taking tan of both the sides, tan y is equal to x. Differentiating sec square y, y का डेरिवेटिव dy by dx, x का डेरिवेटिव 1, राइट? सो dy by dx क्या आ जाएगा? 1 upon sec square y. So do we have any identity? 1 plus tan square theta. So 1 plus tan square y. So tan y क्या था? x. So 1 upon 1 plus x square, right? So similarly we have the derivative of all the inverse functions. So these are the derivative of inverse functions. So sine inverse x, the derivative is 1 upon under root 1 minus x square, as I told you how we derived it. Similarly cos inverse x, the derivative will be minus. So cos और sin inverse में minus का difference है. इसी तरह से tan inverse का derivative is 1 upon 1 plus x square, cot inverse का minus 1 upon 1 plus x square. So what is the difference is of minus sign. Similarly sec inverse, the derivative is 1 upon x square minus 1, and cosec inverse, the difference is of minus sign. So same, you have to learn. This forms a group, this forms a group, and these two form a group. So sine cos together, difference of minus sign, tan cot together, difference of minus sign, sec cosec together, difference of minus sign. So similarly, we will have a question like, we have to find the derivative of e की power sine inverse x. So how will I find the derivative? We know the derivative of ex is always ex, so e sine inverse x, then the derivative of sine inverse x will be 1 upon under root 1 minus x square. So I applied what? The chain rule. The derivative of function and then the derivative of angle. So this is how we differentiate. Question number 9 of exercise 5.3. Now what we have, this is sine inverse, we have to differentiate. Now what will come to our mind? It is, let's differentiate it directly. So I know I can differentiate it directly. So I'll differentiate, write the derivative of sine inverse and then the derivative of this. So it will again be a lengthy procedure. So why not to apply a formula and solve this question, and we used to solve in inverse trigonometry, arrive at a particular solution and then write the derivative. So we know the formula of sine inverse 2x upon 1 plus x square is 2 tan inverse x. Now what is the derivative of 2 tan inverse? 2 upon 1 plus x square. The derivative of tan inverse is this, right? Now let's have question number 10 over here. So question number 10 is tan inverse 3x minus x cube upon 1 minus 3x square, right? Over here, what I'll do is, before differentiating, before applying any rule, what we have to do is, we have to think of, can we remove this tan inverse from here? If I can reduce this function, then my derivative will be easy, right? So what I'll do is, I'll just write x as, let me write x as tan theta. So I'll write it as tan inverse 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. So the moment we write this, we know this is formula of tan 3 theta. Tan inverse and tan will get cancelled. So y is equal to 3 theta. So 3. Now theta was y substituted, so theta can be written as tan inverse, the way we used to do in inverse. Now what do I have? I have y is equal to 3 tan inverse x. So derivative of this is 3 upon 1 plus x square, right? So now next what we have question number 11 and question number 12. Just observe, both the questions, the angles are same, only the difference is of cos inverse function and sine inverse. Over here in question 11, we observe this is cos inverse, a formula of 2 tan inverse. So I'll just write 2 tan inverse and we'll write the derivative as 2 upon 1 plus x square, right? Now, if it is like this, what I'll do? I cannot write the formula, so I'll just put x as tan theta. Why? Because I know 1 minus tan square theta upon 1 plus tan square theta is the formula of cos 2 theta. So we have sine inverse and this is cos 2 theta. So the moment we have cos theta here and sine inverse over here, Can I change? I can change this cos as sine 90 minus 2 theta. Right? So once it is like this, sine inverse and sine will get cancelled. So I'll have pi by 2 minus 2 theta. So in place of theta, I can write tan inverse x. Right? So now if I write the derivative of pi by 2 is 0. 2 tan inverse is 2 upon 1 plus x square. So this is the derivative. Right? So this is how we come out of a particular question. Okay, so next question is question number 13. So again, what do we observe? This is exactly on the same lines as question number 9. Over there it was sine inverse, but we cannot apply any formula over here. So what I will do, I'll just put x as tan theta. The moment I put it as tan theta, it will be 2 tan theta upon 1 plus tan square theta, right? So now next what will happen? So it can be written as what? Sine 2 theta. Now again sine and cos. So what concept will I apply? I'll apply the concept of pi by 2 minus 2 theta. So y is pi by 2 minus 2 theta. Theta can be written as pi by 2 minus 2 tan inverse x. And again the derivative will come out to be minus 2 upon 1 plus x square. Right? Now observe question number 14 over here. Sine inverse 2x upon 2x into under root 1 minus x square. Now the range of x is given from minus this to plus 1 upon root 2. Now if I put x as sine theta over here, so I'll get my answer as sine inverse 2 sine theta, 1 minus sine square theta is cos theta. So I'll get sine 2 theta and so on. Similarly, if I put cos theta, I'll get the same thing. But we cannot put cos theta because over here the range is from minus to plus. And we know that sine inverse has range from minus to plus, but cos has range from 0 to pi. That is why here we cannot put cos theta. This is the most important thing. We can only substitute sine theta over here. So further, I know I can solve this as, this will be sine 2 theta, sine inverse will get cancelled, 2 theta, 2 sine inverse x, which you can differentiate as 1 upon under root 1 minus x square. Over here it is sec inverse. Question number 15, I can put x as cos theta. Why cos theta? Because I know cos theta has the formula and it will help me in coming out of this particular situation. So this is the formula of cos 2 theta. So this can be written as sec inverse sec 2 theta, further 2 theta, 2 cos inverse x, and the derivative 1 upon under root minus 1 upon under root 1 minus x square. Right? So this is how we will solve all the questions which are based on inverse. We will try to reduce them first of all, substitute, reduce, and all the questions with that we did in inverse trigonometry of substitution can come here. Over there we were just solving, and here we will have one more extra step where we will be finding the derivative as well, right? So keep on practicing all these questions, so directly you can link when you are revising inverse, you can directly practice the questions from here as well, right? Keep on practicing the questions which are based on inverse.